G'day further math students. In this video we're going to start to look at transition matrices, and we're actually going to have 2 or 3 videos where we look at transition matrices because there's a lot to understand in this topic. Obviously we know what a matrix is. A transition matrix, well, the word transition just means to change. So a transition matrix is used for questions where values are changing over time. And we usually call the period of time, which might be like, a day or weeks or months or years, we usually call these states, right? So you'll often hear about state matrices as values change over periods of time. There's lots of different examples for what transition matrices could be used to represent. Might be a question about what subjects students are choosing in 2020 and then in 2021 and then in 2022. But as I said, there's lots of different ways that transition matrices can be used. And transition matrices are always square, right? So that's good to understand from the start. And usually, there are some unusual questions where this doesn't happen, but usually the sum of each column will equal 1. All right. In this first section, we're just going to look at how we actually set up these transition matrices and what they represent. Okay. So in example 1, we're given a diagram, and this is pretty common for transition matrix questions. We're given a diagram that represents the weekly return rates of rental cars at 3 locations: Albury, Wodonga and Benalla. So basically what's going on here is you've got 3 towns where you can rent a car, and people can rent the car from these towns, but they can return it anywhere, right? So someone might borrow a car in Albury, then drive to Benalla and return the car to Benalla, because I guess it's the same company. So what we have to do is complete the transition matrix that describes the week-by-week return rates at each of the 3 locations. And we have to convert the percentages into decimals. So let's have a look at how this actually works. And it's maybe not the clearest picture, but I think you can just see the numbers well enough. So let's start with Albury, right? So here's the town Albury, this little A on the diagram. And we have this loop. I'm going to highlight these as we go. We have this loop from A to A, from Albury to Albury, and that says 70%. Now what that means is that 70% of the cars that are rented in Albury get returned back to the same place in Albury, right? So that's 70%, but as a decimal that would be 0.7. Right, so you can see that it's like rented in Albury, returned to Albury, okay, and that's the 70% or the 0.7. Okay. Let's again stay with Albury, but let's look at the percentage of cars that are borrowed in Albury and then returned to Wodonga. So if we use this arrow here, this 10%, that's saying that 10% of the cars that are rented in Albury will actually get returned in Wodonga. Now again, 10% as a decimal, that's 0.1, right? And you can see, you can use the labeling on the outside of the transition matrix here to say, well, it's rented in Albury, returned to Wodonga, rented in A, returned to W, so that's where the 0.1 goes. And we can kind of just continue filling in the numbers using this method. The last number for this column here is the percentage that's rented in Albury and returned to Benalla. So we're looking for the arrow that goes from A to B. And that is 20%. Right, you can see the 20% on that arrow. And you can see that in this situation, the column is adding up to 1, right? As I said, in most cases that will happen, but there are some specific questions where it may not. So don't assume that it'll definitely happen, but in most cases, the columns will add up to 1, right? Because in this situation, the cars have got to be returned somewhere. Excuse me. All right, so now we're going to look at the second column, which represents the cars that are rented in Wodonga. So we're going to start from W. Again, we've got this loop from W to W showing 80%. That's saying that 80% of the cars that are rented in Wodonga will be returned to Wodonga. So it's a 0.8 for that element there. Let's look at Wodonga to Albury. So we find the arrow that goes from W to A, and that's back here. Right, that's 5%. So 5% of the cars rented in Wodonga get returned to Albury. Now 5% as a decimal number is 0.05. And from Wodonga to Benalla, so we're looking for the arrow that goes from W to B on this diagram, and that's got 15% on it. So that's 0.15. Again, if we add those 3 numbers together, we're getting a total of 1. And finally, the cars that are rented in Benalla. So let's go B to A, so Benalla to Albury, is 12%, so 0.12. Benella to Wodonga, B to W, that's 11%, 0.11. And B to B, Benella to Benella, is that loop 77%, 4.77. Right, so that's how we can use a transition diagram, a transition matrix to represent information in a diagram. Right, and this information could have been given in words as well, but it is pretty common in these sorts of questions to be given as a diagram. All right, let's have a look at another example. In this example here, we're given a context where a factory's got a large number of machines, and these machines can either be operating or broken. Right, so they can be in either of those two states, operating or broken. Some machines which were operating one day become broken the next, so some of them obviously break down, but likewise some broken machines get fixed so that the next day they'll become operating. So you've got machines changing from operating to broken or broken to operating from day to day. And in this question we're actually given the transition matrix to represent it, right? So you can see we've got the numbers here, we've got the labels on the outside, so it's a bit backwards to the previous example where we already know the transition matrix, but we're going to be asked some questions about it. So, from one particular day to the next, what percentage of operating machines become broken? So we're really thinking what percentage of operating today become broken tomorrow? And to interpret that from the transition matrix, we're just looking operating today, broken tomorrow, that's the 0.15. Right, so 0.15, but obviously as a percentage, that will be 15%. What percentage of broken machines are fixed each day? So that's talking about going from broken to operating. All right, so that means broken to operating. So broken today, but operating tomorrow, so B to O is 0.05, which is 5%. Complete the network diagram shown by placing a percentage on each edge. So this is the reverse of what we just did in example 1, where we've got to put the percentages onto the diagram. So operating to operating, so operating today and also operating tomorrow is 85%. So O to O is 85%. Operating today, broken tomorrow is 15%. So O to B is 15%. Going to the second column now, broken today but operating tomorrow was 5%, so B to O is 5%, and broken today and still broken tomorrow is 0.95, so 95% on the B to B arrow there. And lucky last, on a particular day there are 25 operating machines. How many of these machines are expected to be broken the following day? Okay, so we know we've got 25 operating machines, and we know also from the transition matrix that 15% of operating machines become broken the next day. So what we need to work out is 15% of 25, right, which we can do as 15 divided by 100 times 25. All right, now if you're not sure, do it on your calculator. You're always allowed to use your calculator. So 15 divided by 100 times 25, 3.75. All right, so probably not the clearest question here. 3.75 machines are expected to become broken the following day. If we were trying to make a realistic prediction, I guess you might say that this should be rounded to the nearest whole number. Given that it's a prediction though, not actually a number yet, it might be okay to leave it as 3.75. So just because the example wasn't super clear, I'll say or 4 to the nearest whole number, and I'll remind myself to fix the example for next year's notes. Alrighty, so I hope that gives you a bit of a sense of how these transition matrices are constructed and how you can interpret the information from them. We'll come back and do a couple more videos to go through the rest of 12C. Cheers.